Hello, my name is Marcelina Lirius and welcome to Math Monday. Today we're going to focus on this standard in Algebra 2, A2, BF, A3, which is describe the effects of transformations algebraically and graphically, create vertical and horizontal translations, vertical and horizontal reflections, and dilations, namely expansion and compression for a variety of functions. Before we start, please be ready with your notebook and your pen. Okay. So for this standard, we will focus also on the two enwrapped expectations. They are describe the effects of transformations graphically using the terms such as horizontal and vertical, stretch, the expansion or shrink, which is compression. We're talking also about translations and dilations. The second is describe the effects of the transformations algebraically using A, H, and K given an equation of the form f of x equals A times the quantity x minus h plus k, or given other forms of the functions. So in this case, we're actually looking at a parent function. Let's say f of x is equal to x to the power n. So when n is 1, we have a linear function. When n is 2, we have a quadratic function, 3 cubic, and so on. Now, what happens if we change the parameters and transform this into the form a times the quantity, or f of x is equal to a times the quantity x minus h to the power n plus k. So what will now be the effect of this a, h, and k parameters on the graphs of functions? So let's review some of the vocabulary words. When we talk about translations, we're talking about sliding an object. In this case, we have the graph here of a parabola. So for horizontal translation, we're actually looking at the movement of the graph from left to right. Okay, from left to right, you slide it along the x-axis. And when we talk about vertical translation, we are actually moving the graph of the function upwards or downwards. Then if we look at this function, f of x or y is equal to a times the quantity x minus h squared plus k, which of these values here affect the translation or the movement of the graph? Then when we talk about reflection, we're talking about flipping, okay? You flip the object or the graph of the function across the y-axis or, okay, across the x-axis. So we now have our vertical translation or reflection. You flip the object across the x-axis, and for horizontal reflection, you flip the object across the y-axis. Then we'll look at which of these parameters will affect the transformation. Then we now have dilations. So when we talk about dilations, we're talking about compression or shrink. You compress the graph, or the graph moves closer to the y-axis. And when we talk about expansion, we're talking about the stretch. Okay, that means it widens, the graph widens or it moves away from the y-axis. Which of these parameters will affect the transformation or dilation? Will it shrink, or what affects, or which value will now change the graph or expand or shrink the graph? Okay. We will start with our parent graph. Again, this is a parabola. So if we have our f of x is equal to x squared, okay? This is a parabola with vertex at the origin, whose coordinates are 0, 0. And notice here on the left side, I use Desmos Calculator. So this is now our original graph transform, okay, x squared. So you now have a, h, and k here. So our value for a is 1. In this case, we have h is 0, k is 0. So we are going to change the values of a, h, and k and figure out what transformation occurs. Okay, this is our parent function again. So let's look at these two graphs and let's look at the parameters. So when I change the value of a from 1, okay, to 4, so in this case, a is equal to 4. Notice that the graph, compared to the parent function here, the graph shrinks. Okay, it shrinks and moves closer to the y-axis. Okay, it becomes narrower. And on the second graph, when a is 0.1, okay, it's smaller, and it's a value between 0 and 1, it's a decimal. Here, 0.01, notice what happens to the graph. Okay, the graph is expanded, or there's a stretch, or the graph widens. So I'll stop here and process the information. Okay, when a is 4, we have a shrink. When a is smaller, it expands. The graph expands. Okay. In this case, both values are positive. Now, when we change the value of a, okay, a here, still 1, and we're going to change the value here, okay, a is 1, and on the second graph, again, we also have our h and k 0 in both graphs, but the difference is that on the first graph, a is 1, and on the second graph, a is -1. What conclusion can you arrive at when we change the value from positive to negative? So a equals 1, okay, the graph opens upward, and when a is negative, the graph opens downward. So that is a vertical reflection. Okay, next. Let's move on to horizontal translations. Which of these values? So let's start with the parent function. Again, you have this y equals x squared. And you now change the value. A is still 1, h is 0, k is 0. This time, we're going to change just the value of h, okay? We have h is k, but our k is still, h is 4 and k is 0. H is 4. So notice that from 0, 0, from here, our graph was moved to the right. Okay, so you now have x minus 4. You now have the coordinates of the vertex. Look at the coordinates. This is now moved to 4, 0. Okay. And when our x, on the second graph here on the right, here, notice the difference. This is h is 4, and here h equals -3. So h equals -3. Notice the coordinates here. It's -3 and 0. It's a movement to the left. It's a slide, horizontal translation. This is affected by the value of h, okay? It's the value of h that affects this movement. Slide h, okay? Take note of that. Then when we talk about vertical translations, we're talking about the movement of the graph up or down. So if we have the parent graph y equals x squared, again, our a is 1, we put our h 0 and k 0. We will compare these two graphs here. So in the first graph, okay, again, you have a 0, k 0, but we change the value of k. In this case, k is equal to 3. So the transformation, if you know how from 0, 0, when you change the value of k to 3, the vertex now is at the point 0 and 3. Okay, and on the last graph here, we change our value. Again, your h is still 0, but your k is -4. You compare this is at 0, 0. Now, this is at the point 0, -4. So it's actually the value of k which affects the transformation. And also, notice the change in the coordinates of the vertex, 0, 0 to 0, 3, 0, -4. So again, this vertical translation, when we change the value of k, it changes also the value of, it moves the graph up or down. Okay, take down some notes before we move on to the to graphing this using Desmos Calculator. So now using Desmos Calculator, we're going to summarize all these transformations by changing the value of the parameters. So earlier we said the value of A affects the, we're talking about dilation. Either it stretches or shrinks the graph, or also it moves or it reflects the graph upwards or downwards, okay? So here, I'll just press in A here is equal to 1. But if we change the value of A, it moves, okay? Shrinks up or down. Widens or narrows or widens if you move it. So this is how it changes. So if you make it bigger towards +10 here, then going back, it becomes smaller and smaller until at this time, when it's negative, it now reflects downwards. So in this case, notice the graph here, A, the value of here is -3.5. It's negative, so it's downwards. Then, so when we change the value of h, we take our A constant. We're not changing the width or nor reflecting it across the x-axis. Let's change the value of h. In this case, when your h is positive, it moves to the right, so h, so that means h. Then it moves to the left when it's negative. Okay. Then, what's the effect of changing the value of k? So I move the k. Notice it's a movement upwards or downwards. Okay. So for your practice, I want you to Google Desmos Graphing Calculator and just click on, look for the parabolas in vertex form. Then you can just play around and just change the values of A, the value of H, then the value of K. So that concludes our lesson for today, and I hope to see you next week.